So now we will see the effects of pH on growth of different microorganisms. As we have been discussing that there are different factors of growth for microorganisms to grow in food. That is why we need to understand these concepts in a sense that we can control these conditions for the growth of microorganisms. We can make it unfavorable condition for the growth of microorganisms in our food, and that is why we can increase the quality as well as the life of food, and the food can be made available for a longer time. So pH is one of the very important criteria that has to be taken into consideration for designing different foods and looking at their shelf life. This pH is defined as the negative logarithm of hydrogen ion concentration. Why we have done this to create this negative log value for the pH, because we wanted to know, we wanted to have a easily understandable system for pH. It gives us a range of pH from 1 to 14, so it gives us a distinct number that can tell us about the acidity or alkalinity of any food. So as you know that 7, as we say, 7 is a neutral pH. So if you go below 7, it is all acidic. It can keep on increasing from 6 to 1. And similarly, if you go above 7, the pH is alkalinity. So we are calculating the activity of hydrogen ion concentration. In other words, this can be linked with the acidity or alkalinity of food, and that has got effect on the growth of microorganisms or the range of growth of microorganism in a specific food. And that is why we would see that certain kind of food would be spoiled by a certain type of species of certain microorganisms and not the others. So we can manipulate the pH for different foods, whether we can reduce it or we can increase it to the optimum condition for growth of any specific microorganisms. So it can be changed in a way that we make it unfavorable for the growth of microorganisms. In order to do that, we need to understand our microorganisms, whether they are pathogenic or spoilage, what is the pH range in which they prefer to grow. So if you look at this graph, this tells us about the different ranges of growth of microorganisms. As it is evident that most of the organisms or pathogens, they thrive at the pH range. So 4 to 9 is the range of pH in which we can see the maximum microorganisms they grow. But then there are exceptions as well. For example, we have molds. They would be growing from 2 to 10. So they have got a very wide range of pH in which they can grow. They can grow even in conditions where we don't see the growth of other microorganisms such as yeast or bacteria. So they have got a wider range. The next one, the outlier is of course yeast. It has got 2 to 7 pH. Yeast would not grow in the alkaline conditions. It needs the acidic conditions, and the range of yeast is 2 to 7 pH. Then if you look at lactic acid bacteria, which I earlier said that they are very desirable bacteria for a lot of health benefits, as well as they add a lot of variety to our food. Lactic acid bacteria are necessary for production of yogurt and cheese and a lot of other valuable products such as pickles. The lactic acid bacteria grows at pH 3 to almost 9. So this is pH in which lactic acid bacteria can grow. If we want to have the growth of lactic acid bacteria, we need to have an optimum pH range for lactic acid bacteria. Now let's see some of the very serious pathogens. For example, Salmonella, Clostridium botulinum, Bacillus cereus, E. coli. They are all pathogenic microorganisms. They are involved in serious disease, food safety concerns. we need to be really careful, and we need to understand what are the temperature pH range in which these microorganisms grow. So the Salmonella grows from 5 to 9 pH. So if we can make the pH, if it's possible to adjust the pH of food below 4 or above 9, we can reduce the incidence of salmonellosis in many cases. Similarly, Clostridium botulinum has got a narrow range of 5 to 8 pH in which it can grow. Bacillus cereus has got similar pH range. Again, E. coli is another important food pathogen that can be controlled if we know the pH range in which this grows. Campylobacter is another pathogen growing from 6 to 9 pH. So this graphs, actually this information is very useful to understand that what is the kind of microorganisms we are dealing, and what is the pH range of desirable or undesirable microorganism within food. For example, again summarizing that molds normally grow from 1 to 11 pH range, yeast would grow 2 to 7, bacteria can grow at 3 to 9 pH range. So if we can control these pH for a certain microorganism, then of course we can have better shelf life. For example, if we go above 14, there would not be any growth of molds that can be controlled. Similarly, 2 to 7 is the range for yeast, so we have to go either below 10 or above 7 to control the growth of yeast, and then bacteria 3 to 9 pH, so within that. But it's not always possible to change pH. In certain cases it is possible. In certain foods it's possible to change pH in a way that food is still acceptable. For example, acetic acid fermentation. That is a preservation process in many of the fermented food products where the acetic acid is formed, and that makes the end products, for example vinegar, that has got a pH range, a very acidic pH range that would stop the growth of many microorganisms. That is why we go for some of the fermentation processes as well. The same happens in the case of formation of yogurt, as we earlier discussed, that the yogurt pH is more acidic than milk, so yogurt has got more shelf life than milk. And same is true for all the pickled vegetables as well. If we can pickle the fruits or vegetables, we can produce certain acids that reduces the pH of these foods. So that would make it having longer shelf life. So that is why you see that most of the pickles, they would have higher and a very longer shelf life. But again, they might fall in a range where we can see the growth of mold and yeast on that. And that is sometimes we observe that pickles get moldy, or they can have visible growth of molds on them. So we need to look at the pH. If we can change that to a new pH or different pH in which the pathogenic or spoilage microorganisms cannot grow. But as I said again, it's not always possible to change the pH in this in a way that the food still remains acceptable. So that was all about the effect of pH on food and the growth of microorganisms.